Hello students, welcome you all in this video where I am solving science model question paper 4 for the year 2025-26, and in this video I am going to solve 4 marks question from part B chemistry. So let's start with the question. So in this section, that is section number 10, we are going to solve one question and which carries 4 marks. So here we have an internal choice for this question. So we'll start with question number 25, which is divided into sub question A and B, which is there on the next page. So we will start with A. So 25 question says give reason. So here the question is carbon atoms neither form C4 minus anion nor forms C4 plus cation. So carbon atom will not form C plus 4 as well as C minus 4. We have to give the reason for this question. So we'll start the answer. So first I have divided this question into two sections. In the first section I am going to explain the reason why carbon will not form C plus 4, and then in the second I will explain the reason why carbon will not form C minus 4. So we'll start with the first one. Why carbon does not form C4 plus cation? So the answer is to form C4 plus carbon would have to lose 4 electrons. Now see here, carbon atomic number is 6. The meaning is it has 6 electrons and 6 protons. So see here, protons are 6, electrons are 6. So if I write the electronic configuration of this carbon, so see what will happen, K, L, M, N. These are the shells. So first K will take 2 electrons, so remaining is how many? 4 electrons. So remaining 4 I will add in the L. If you see, L is the last shell, or I can say valency shell. So this is the last shell. Last shell should attain octet, then only it will become stable. Octet means what? It should have 8 electrons, then only it is called as it has attained octet. Now to attain octet, this last shell either it has to take 4 electrons, then it will become 4 and 4 8, or it has to lose these 4 electrons. If it lose this 4 electron, then the last shell, the L shell will become empty and the K shell will become the last shell. And what is the capacity of K shell? It is 2 itself. So it will attain stability. So therefore, here they have given two sentences that carbon either it has to lose or it has to take 4 electrons, but carbon never lose 4 electrons, never gain 4 electrons. It will share electrons. So we have to give the reason for this. Now see, to form C plus 4, it has to lose 4 electrons. If it lose this 4 electron, imagine how many electrons will remain? Only 2 electrons will remain. But what about protons? Protons will remain 6 itself. So therefore, protons means positive. Positive charge will be extra, and that's why C will be written as plus 4. Next, removing 4 electrons requires very large amount of energy. That is nothing but very high ionization energy. We know removal of electron is called ionization. Remember this process. The process ionization is nothing but removal of electron. If you want to remove 1 electron also, you require energy. That energy is called as ionization energy. And in this case, we have to remove 4 electrons. So it requires much amount of energy. That is very high ionization energy is required, which is not possible, which is very difficult. Next, after losing 4 electrons, carbon would have only 2 electrons left, which is highly unstable. If it gives this 4 electrons, if it lose 4 electrons, carbon will have only 2 electrons. And how many protons? Protons will be 6. So here it will be highly unstable state. Then the next reason, therefore, formation of C plus 4 is energetically unfavorable. And because of this, all the reason, it is very difficult for carbon to form C4 plus state, that is cation. I hope you understood this explanation. I'll repeat once again. First one, removing 4 electrons requires high amount of energy. And second one, if it loses 4 electrons, then the remaining electron will be only 2 and protons are 6. So this state will be highly unstable. Now we'll come to the next, that is why carbon does not form C4 minus anion. Now see what happens if carbon takes 4 electrons. Already it has 6 electrons. 6 plus 4 will become how many? 10 electrons. So carbon will become 10 electrons if it becomes C minus 4, but protons will be only 6. So positive charge are 6 and now the negative charge is 10. It is not at all balanced. Now see what is the reason? To form C4 minus, carbon would have to gain 4 electrons. Correct. Next, The nucleus of carbon has only 6 protons, so it cannot strongly attract 4 extra electrons. So as I told, carbon has only 6 protons and it cannot handle this extra 4 electron negative charge. The next reason, adding 4 electrons would cause strong repulsion between the electrons. Already there are 6 electrons in this, and if you add another 4 electrons, there will be repulsion between the carbon electrons and the extra 4 electrons which you are adding. Next, this would make the ion highly unstable. So because of this repulsion, the carbon C-4 will become highly unstable, and therefore the formation of C4- is also not possible, and that's why carbon will not form cation C4+, it will not form anion C4-. It will share the electrons and forms covalent bond. Remember this. So this is the reason for this question number 1. Now we'll see another question in this. Ethanoic acid known as glacial acetic acid. We have to give the reason for this. So ethanoic acid, that is acetic acid, is also known as glacial acetic acid. So the answer is ethanoic acid is commonly called glacial acetic acid. The reason is pure ethanoic acid freezes at 16.6 degrees Celsius. So see here, our room temperature say it is 20 degrees Celsius. So below this 20 degrees Celsius at 16.6, this acetic acid gets freeze and it forms ice-like crystals. When it gets freeze, it converts into solid state and it forms ice-like crystals. So it looks like glacier. Glacier is nothing but ice. So it looks like glacier, and therefore the name is given glacial acetic acid. Very simple reason for this question. Now we'll see the next question, that is B. As I told, 25 question has A and B sub options. So we have completed A. Now we will see the B option on the next page. Now the B question is, write the structural formula of the following carbon compounds. So here we have two compounds, butyne. We have to write the structure for this, and cyclohexane. See here, in butyne, if I divide this word but is nothing but 4 carbon. You have to remember this, 4 carbon. And ine, Y-N-E, is nothing but it has triple bond. One triple bond. Carbon, carbon. In between two carbon, it has one triple bond. So use this hint and draw the structure. So first I'll take 4 carbon, and in any 2 carbon, I will draw first triple bond. See here, triple bonds are ready. And remaining all the carbons will have single bond. Now balance all the valency of the carbon. Carbon valency is 4. So we have to balance it. So see the first carbon. Let me number the carbons. So it will be easy. 1, 2, 3 and 4. Now see the first this. Carbon number 1. It has already 3 bonds here. So it requires only 1 bond. So I'll write it here 1 bond. If you see carbon number 2. Left side it has 1 bond, right side it has 3 bonds, so it has balance its valency, no need to write any hydrogen for this. Third carbon, here there is 1 bond, you can see left side, and right side also it has 1 bond, so another 2 bonds are required to balance the valency, so I'll write with H and H. If you see fourth carbon, it has only 1 bond on the right side and requires another 3 bonds to complete its valency, so I'll write it here 3 bonds with 3 hydrogens, and this is only the structural formula of butyne. If I combine and write, it will look like this. So let me write it once again. So it will look like this. See, CH3, CH2, C, triple bond CH, and this is nothing but called as butyne. So this is the structural formula. Now if you see the next one, cyclohexane. Now split this word cyclo. Cyclo means it is consist of ring, closed ring. Hex. Hex means it consists of 6 carbons. So I'll write it 6 carbon. Ane. Ane means what? All the carbon consist of single bond. So I will write it single bond. Now everything is completed. Hint is ready. Now we have to draw the structure. Ring. It has a ring which has 6 carbon. So I'll write 6 carbon 1, 2, 3, 4, 5 and 6. So I have to draw closed ring with single bond. So carbon carbon has a single bond, single bond, single bond, single bond, single bond and single bond. So I have completed the first one, ring, 6 carbons and single bond. Now we have to balance the valency. Now check every carbon. I will number it first. So 1, 2, 3, 4, 5 and 6 carbons are ready. For first carbon, it has already 2 bonds. So another 2 bonds are required. Same way, second carbon also has 2 bonds. Another 2 bonds are required. Wherever we require the bonds, we will write it with hydrogen. So see here, I am balancing the valency of every carbon by writing hydrogen. This is the structural formula of cyclohexane. If I combine and write the structure, see carbon number 1 will become CH2, 2 will become CH2, 3 will become CH2, this is also CH2, CH2, and this 6th carbon also becomes CH2. And this is also the structure formula of cyclohexane. Remember, these both the structures are same. This is little bit of combined and this one is in a complete split structure. Even this and this both are same. Here this one is combined one. So this is the answer for sub question B. Now we will see the next question in the next page. So as I told, this question has an internal choice. So we are going to solve the next OR option. This is again divided into A and B. First we will solve A question on this page. Explain the mechanism of cleansing action of a soap. Very important question. Many of the question paper, this question will be repeated. So remember, always practice this question, very easy to answer. So here we have to explain how soap cleans dirt from the clothes, and that is only called as cleansing action of the soap. So we'll see the answer for this. So what is soap? Soap is nothing but it is a long chain of sodium salt of carboxylic acid. Carboxylic acid, long chain of sodium, or you can say potassium salt of carboxylic acid. And the process used to prepare soap is called as saponification. Remember, the name of the process to prepare soap is called saponification. Soap molecule have two parts. One is hydrophilic part or hydrophilic end, also called as water loving. Second is called as hydrophobic end or water repelling. So if you tell me to draw, roughly the structure can be shown like this. So this is the structure, and here there will be COO minus Na plus. So like this the soap molecule is shown. In this zigzag structure is nothing but the long chain of carbon, and this end is called as hydrophobic. I'll write it here, hydrophobic end, or I can say water repelling. So remember, this end is called water repelling. So it will go away from the water. This end is called hydrophilic. Hydrophilic. What is hydrophilic? It is water loving. So it get attracted toward the water. So these are the two parts present in a water single soap molecule. Now see the next. The hydrophobic tail attaches to oily dirt or grease. So here hydrophobic tail or hydrophobic end, that is water repelling. Water repelling means what? It will attract the organic part or the oil part. So this part will get attracted towards the dirt or the grease. And hydrophilic end, that is water loving end, it will remain in the water. You have to remember this, it will remain in the water. What is dirt? Dirt is consist of oil plus dust. And what is this oil? Oil is nothing but organic part. Organic. Hydrophobic. This hydrocarbon end is also organic, and oil part is also organic. So this organic will get attract towards each other. But this end is hydrophilic, and therefore it will get attracted towards the water. Water will get attracted towards each other. Now, many soap molecules surround the dirt particle and they form circular structure called micelle. The dirt get trapped inside. Now see what happens. Once we take a beaker or take a tub, take water and add one cloth which is having dirt at the center. In this, when we add soap, the soap molecules which will be looking like this, the zigzag end and then functional group, zigzag end and again functional group. So like this. So these all soap molecules, because of their hydrophobic end and hydrophilic end, all will come closer to each other and they will arrange in the form of circle surround this dirt. So dirt will remain at the center. Dirt will remain at the center. What is this dirt? This is a organic part, that is nothing but a oil part. Hydrophobic end of this soap molecule will get attracted towards the dirt like this, and all the soap molecules will arrange in the form of circle by keeping their hydrophobic end towards the dirt and by keeping their hydrophilic end away from the dirt. And like this, the structure will be formed, and this structure is called as micelle. Remember. So here I have taken the diagram from the NCERT book. You can see here. So this yellow colored is a oil droplet or a dirt on the cloth. Once the soap is added, all the soap molecules arrange in such a way that their hydrophobic end will remain towards this oil here, and their hydrophilic ends remain away from the dirt but towards the water. Like this, the arrangement takes place around the dirt, and this is only called as, this whole structure, it is called as micelle. Now the next, once the micelle is formed, you can see here dirt will be trapped inside this micelle at the center. The outer surface of the micelle is water loving, so the dirt is carried away with the water during rinsing. So this outer is water loving, so it will be attracted towards the water. See here, water will be pulling towards itself, and this hydrophobic end will be attracted towards the dirt. And therefore, once when we rinse the cloth in the water, this dirt will be broken into pieces and it will be carried away by each soap molecule in the water, and the cloth will become clean. And this is the cleansing action of the soap. I hope you understood. Remember, students, whenever such type of question comes or this question comes, this drawing this micelle molecule is very important. When you draw the answer like this in the points, and if you explain, if you draw this micelle structure in your answer will be complete and you'll get the whole marks for this question. Now we will see the next question on the next page. Now the next sub question, that is B, write the differences between saturated and unsaturated carbon compounds. So here we have to write the differences between both. So as I have told, whenever the question comes, write differences, try to write in a column. Try to write in a column. It will be very easy for the examiner to answer. So let me write my all the answers in a column. So you can see here now it is correct for writing the answer for differences. Now see, one side I have written unsaturated carbon compound, other side I have written saturated carbon compound. Now in this saturated and unsaturated, we'll write the differences. So first difference is saturated means it contains only single bonds. So with respect to this, here we have to write contains double or triple bonds. So here it is double and triple. In saturated, it is only single. Second one, also called alkanes. So all single bonded hydrocarbons are called alkanes. Respect to this, we have to write all called alkenes and alkynes. So double bonded are called alkenes, triple bonded all called alkynes. Now, third difference, all saturated carbon compounds are less reactive because they have single bonds. And here we have to write all alkenes and alkynes, that is unsaturated compounds, are more reactive because they have single bond. They have pi bond as well as sigma bond. So sigma, here two pi bonds, and pi bonds are very weak. So therefore these are highly reactive or more reactive. Next difference, do not undergo addition reaction easily because they are less reactive. They will not undergo any addition reaction easily. By some using some special methods, we can do the reaction, but easily they cannot show any addition reaction. But if you see unsaturated alkenes and alkynes, because they have double bond and triple bond, undergo addition reaction easily. Pi bond will break, electrons will become free, and you can do your hydrogenation, chlorination, addition, etc. So therefore, unsaturated will show addition reaction easily and saturated will not show easily. Next is example. Example is ethane. So here single bonded means what will take? Ethane. So carbon, carbon, single bond, H, H, H. So see here, this is example ethane. But in case of unsaturated, we can take example of carbon-carbon having double bond or carbon-carbon having triple bond. So see here, this will be the example, as well as this is also the example. So this is C2H4 alkene, that is ethene, and here this is C2H2 alkyne, that is ethine. So here these are the differences between saturated and unsaturated compounds, which is very easy to answer. So here we have completed 4 marks question from part B chemistry. With this, we have also completed part B chemistry for this model question paper. After this, I will solve with part C biology questions. I hope these all the questions will help you to prepare for your final exam and to take good marks in your exam. So if you like my videos, please share my videos with your friends, and if you're getting little bit of the help from these all the videos, please consider subscribing my channel. Thank you so much.